Hi, welcome again to another session in this course. We are still on list operations in Python. In this session, we are going to be looking at pop function or pop method. This method is used specifically with lists and it removes and returns the item at the given index. Those two words are very important. It removes and then it returns. We are going to be saying that as we continue. It can only pop one element at a time. So which means that if you want to pop more than an element at a time, you are going to be probably using a, a for loop or any form of other loops. But at a time, it can only pop one element of a list. If no index is specified, it removes and returns the last item in the list. So if we just call the pop command or the pop method rather, if we do not specify an index where that particular element should be popped, then it is going to pop the last element of that list. So let's get at it. This is my list. So let me call it out. So you can see now that it contains four elements. So if I say let's pop the third element, which is index 2. This 0, 1, 2. So let's pop the third element, which is index 2. That is going to be 3. And then let's see what we have. So now the third element, which is index 2, has been popped. Then what is our list now? So you can see that my list now has 3 elements instead of 4 elements that it had initially. So this is how pop method works. Let's look at it here again. Now let us look at if we do not specify any index. So let's say my list again. So we have 3 elements now. So let's pop it. So let's check our element again, our list again. So we can see now that when we specify an index, that particular index is going to be popped. However, if we do not specify it, it is going to pop. So we can see now that if we pop an element with an index specified, it is going to pop the element at that particular index. However, if we do not specify the index, it is going to pop the last element of that list. Now, I want us to see something here. Let's do it like this again. Let's say my list. So let's say pop element. Now, if I call on pop element, what do we have? So which means that if I use pop to remove an element from a particular list, that list can be stored in that element that was removed can be stored in a new variable. So assuming I have a particular list, I want one of the members to be removed. If I remove it with using pop method, I can still recall that particular member again because I can save it in a new variable. And that is very, very important going forward. Now, let's look at pop and indexing. If we want to get a particular element out of a list, we can use indexing for that. However, we can also use pop for that too. The only difference is that pop is going to remove that particular element from the list, while indexing will only give like a copy or let's say reference it. And let's look at an example here. First, we have four elements, this three and a string. Second also has the same elements as the first. Now, let's check for first based on the index 3. That is the fourth element. And then let's check using pop 2. So now, based on this, we have been able to extract this fourth element, which is index 3 out, using both indexing and pop function. So the first one here is using indexing, and the second one is using the pop method. Now, let's check our first and second again and see what has happened to the list. You can see now that indexing does not affect the list, whereas pop has affected the list. So this is very important going forward too. We want to look at slicing in list. We can slice a list, and it's basically a way to create a new list that is a subset of an existing list. But we have to do that by specifying a range of the indices. So if we want to slice a list, we have to tell Python that this is the part I want to slice out. And this is the way I want it to be done. So it provides a concise way to extract a portion of the list. So the syntax is like this. So we have the new list, we have the original list, we have the starting index, then we have the ending index, and we have the step. That is how we want this to be done. So when we do an example now, you will see that the starting index, if omitted, it defaults to 0. We are going to see that too. And the ending index too is exclusive, so that, like we said before, if we put 4, it means that it will end at 3. So it's exclusive. We are going to be seeing that too in the example. And if omitted, it defaults to the length of the list. We will also see this in the example too. Then step. The step size is for selecting the element. So if omitted, it defaults to 1. So if you want your steps to be 1, you don't need to specify it because it's the default. However, if you want to use anything apart from 1, then you will have to specify it. So let's start with this. So this is my items. So let me call it out. So we can see now, let's say we want to get from 55 to 567. 55 to 567, what do we do? Let's say new item. So my items, so where are we starting from? We are starting from 55. So 55 is at index 1, so 0 1. So it's going to start from there. And then where do we want to end? We want to end at 567, isn't it? So this 1, 2, 3, 4, 5, 6. So because we want to stop at this point, this is 6. Let's count again. 1, 2, 3, 4, 5, 6. If we put 6 here, it is not going to return 567 because of the exclusive nature of slicing. So we are going to put 7, and let's see what we have. You can see now that it returns 567. Whereas if you put 6, because it is 1, 2, 3, 4, 5, 6, it's not going to return 567. Let's see. You see now, it doesn't return it. So that is the exclusive part of it. However, if I do like this and I do not add the end index, what do we have? We are going to have the whole length starting from here. So if you do this, you're going to start from index 1 and to the end of the list. So that is very, very important. Now, if you want to do the stepwise manner and you want to put the step like we explained there, then let's look at this example. Let's start from 2. If we put 1 is going to do what we did in the previous example. And that is why if you want your slicing to be done for each element within your range, then you don't need to specify the step. But if it is going to be more than 1, you have to specify it. So what does 2 mean here? 2 means that, let me delete this. 2 means that if I want to slice like this, it will start from 1. So this is 1, which is 55. And then it will want to go to the ninth index, 1 to 8. That is 1, 2, 3, 4, 5, 6, 7, 8. So I'm sorry, it's not the ninth index rather. It will go to 8, but you know that 8 is not inclusive. So our range is going to be between 55 and 66. This will not be included because it's the eighth one. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8. 8 is not going to be included. We know why. Now, when I count from here, this is the first, so I put it down. I will count the second. The second element after it. This is the first element after it, second element after it. So we have 78. So after 78, the first element is 99, and then the second is 234. So after 234, the first element is 57, and the second is 66. So we have 66. So this is what our output is going to be. So let's see if we are correct. So you can see that we are very correct, and that is how it is done. So let's go a step further. 3. So it means that our first is going to be 55. So 1, 2, the third. Then the next is going to be 99. Then let's check again. 1, 2, 3. The next is going to be 66. So let's try that again. So you can see that we are also correct. So this is how slicing in list is done. And this is very, very important. Good. Now let's check our new item if it has been affected, or our my item rather. So you see that my items has not been affected at all. So slicing does not affect the original list. What it does is that it helps us get access to the subset of that list. Good. Now let's look at the remove method. It is used to remove the first occurrence of a specified element from the list. So if we have a list, we want to remove a particular element from that list, then we used the remove method. So this is it here. This is my list. If I say my list dot remove 3, it's going to remove the first 3. It's not going to remove this particular 3. So and this is why you can see the output here. Now, if I want to remove 5 from this now, I can just put that 5 and then you can see it has removed the 5. Good. So the remove function works like this. So we can see that pop remove, but you have to specify the index. So which means that if you can remember the index of a particular element, you can use pop to remove it. But if you don't know the index, but you know that exact value, you can use the remove method. However, if you know a particular element, you can use the in or not in operator to check whether that particular element is inside your list. And if it is inside your list, you can use the index method, which we explained in the previous video, to actually locate the index of that particular element in your list. So you can use pop or remove anyway, depending on what you are going to be doing. But the cardinal difference between pop and remove is that when you use pop, whatever you have removed from that particular list, you can still access it back, like I explained earlier. However, if you use remove, you cannot get it back. So let's look at this. List 1 and list 2 are the same thing, and then you can see that we have removed 3 from the two lists. But when we use pop, we specify the index, which was index 2. But when we use remove, we have to specify the element itself. However, if we want to access this 3 again, the pop will allow us to do that, whereas remove will not allow us to do that. And you know how to go around that based on what I have explained earlier. Good.